Distress in RCC structure. Distress means damage. Concrete may suffer distress or damage during its life period due to a number of reasons. Because of the varying conditions under which it is produced at higher locations, the quality of concrete suffers occasionally either during production or during service conditions, resulting in distress. Distress in structure. The causes of distress of concrete structures. Structural causes includes externally applied loads, environmental loads, accidents, subsidences, errors in design and detailing, poor construction practices, construction overloads, drying shrinkage, thermal stresses, chemical reactions, weathering, and corrosion. Tools for evaluation of concrete structures. The various tools available for evaluation of concrete structures are as follows: visual inspection and observations, questioning of concerned personnel, scrutiny of field data and records, design checks, NDT, extraction of cores and testing, supplementary laboratory techniques, load testing of a structural member, the general approach adopted for pre-repair evaluation of distressed concrete structures, visual inspection and observations, ambient conditions, crack width and patterns, spelling of concrete, color, texture and rust stains, sinking of columns, failure of beam, column joints, malfunctioning of machinery, structural components and so on, condition of fixtures, deposits, splashes on structural components. The laboratory tests generally adopted are cement content of hardened concrete, chemical analysis, chlorides, sulfates, pH and nitrates. Corrosion of reinforcement in concrete. The damage to the concrete due to corrosion of reinforcement is considered to be one of the most serious problems. It is an universal problem and property worth of crores of rupees which is lost every year. Due to corrosion problem in bridges, buildings and other RCC structures, India incurs heavy loss of about rupees 1500 crores annually. This paper deals with various causes of corrosion and remedial measures thereon. Causes of corrosion and remedial measures. Presence of cracks in concrete. Certain amount of cracking always occurs in the tension zone of RCC depending upon the stresses in the reinforcing steel. Through these cracks, oxygen or seawater ingress into concrete and set up good environment for corrosion of reinforcement. Maximum permissible width of elastic cracks in RCC members would depend upon environmental and other factors. For normal environmental conditions, a maximum crack width of 0.3 mm for protected internal members and 0.2 mm for unprotected external members may be recommended. What is carbonation? Carbon dioxide from the atmosphere diffuse inside the concrete react with calcium hydroxide to form calcium carbonate which is water soluble. This reaction is known as carbonation. Carbonation lowers the alkalinity of the concrete and reduces its effectiveness as protective medium. The pH value of pore water in concrete is generally between 10.5 to 12, but if due to carbonation it is lowered to 9, and below the medium covers to acidic type and corrosion of reinforcement begins. Causes of cracks in concrete. The principal causes of cracking are discussed below. It will be benefited of informative to professional working either for design, construction or maintenance and repair. Temperature and plastic shrinkage. It is often seen relatively straight parallel with the span of floors. This is mainly with one-way slabs for corridors of large length and is due to inadequate provision of distribution steel. IS 456-2000 suggests that minimum reinforcement in slabs in either direction shall not be less than 0.15% for mild steel reinforcement and 0.12% for high steel strength deformed bars of total cross-sectional area to avoid shrinkage cracks. Cracks repair by routing and sealing. The crack sealers should ensure the structural integrity and serviceability. In addition, they provide protection from the ingress of harmful liquids and gases. Routing and sealing of cracks can be used in conditions requiring remedial repair and where structural repair is not necessary. The method consists of enlarging remedial repair and where structural repair is not necessary. The method consists of enlarging the crack along its length on the exposed surface, called chasing or routing, and sealing it with a suitable joint sealant. Providing additional reinforcement. The cracked reinforcement concrete bridge gird can be successfully repaired by using epoxy injection and reinforcing bars. These techniques consist of sealing the crack, drilling holes of 20 mm diameter and that intersect the crack plane at approximately 90 degrees, filling the hole and crack with injected epoxy and placing a reinforcing bar into the drilled hole. Typically, 12 to 16 mm diameter bars extending at least 500 mm on each side of the crack are used. The epoxy bonds the bar to the sides of the hole. The epoxy used to rebond the crack should have a low viscosity. Cracking repair by grouting. Based on grouting material used, there are three methods: Portland cement grouting, chemical grouting, and epoxy grouting.